Okay. And we left off in lecture yesterday, losing track of my days, with limiting reactants, and we're getting ready to introduce molarity so we can move on to solutions. But there was a couple of things that I wanted to go over to have the last of our review done and behind us. And one of those is balancing chemical equations and doing our limiting reactants in a little bit more detail than we did. And that way you're all ready to go. And so let's just look at how this question is worded. Nitric oxide is produced from ammonia and oxygen reacting, and we're using 75 grams of ammonia and 150 grams of oxygen. How much nitric oxide can be produced? So first things we got to do is write a balanced equation. So let's start there. Let's see, I have ammonia, NH3, reacting with oxygen. And that's going to produce, look at this, and you go, NO. Cool. But I got hydrogen laying out there. So one of the things I need to infer from that is not only is it producing nitric oxide, it's also producing water. Cool. So let's start with just a little trick of looking. I have 2 hydrogen here and 3 hydrogen here. So I have to have the even amount on both sides. So I'm looking at kind of like a common factor here. So I'm going to start by just guessing if I multiply that by 2 and this by 3, what do I get? Let's see, and I'm also know if I have 2 nitrogen there, I'll have 2 here. So we'll start there. So see, I have 2 nitrogen, cool. Let's look at my hydrogen. I have 3 times 2, 6. 3 times 2, 6. Life is looking good. But then I go, uh-oh. I have 3 times 1 is 1 oxygen plus 2 times 1. That would give me 5 on my product side and only 2 on my reactant side. Well, so even if I go like a 3 here, that's a problem making that an even number. That tells me that no matter what I do, I've got to make that an even number. So let's just try, because we need to keep these things balanced. If I multiply the 3 by 2, that gives me 6. That means, let's see, I have 12 here. I had 2 here. So let's see. That needs to be 6 as well. Wait, I did bad math. 4. Shouldn't have erased the number. I'm going to increase both by 2. That keeps my hydrogens balanced. So let's just double check. 4 times 3 is 12. Cool. 6 times 2 is 12. Beautiful, my hydrogen. Now I need to change my nitrogen, because now I have 4 there. Let's make this a 4. Okay. So now I have 4 oxygen plus 6, so 10. So that tells me that I have to have a 5 here. So 5 times that subscript gives me 10 oxygen. 6 times 1 is 6. 6 times 1, or 4 times 1 is 4. So 4 plus 6, 10. I'm balanced. Cool. Right. I'm given 2 different starting quantities for my reactants. One is, let's see, what are we given? Do different highlighted color. Pink. 75 grams of ammonia and a different color, 150 grams of oxygen. So you have to know this about me by now. I'm not going to make what looks like it should be the limiting. And if I do, it's because I'm going to expect that you assume that you know which one I'm going to make the limiting. And the whole purpose of this is to make sure that you know how to actually check it, right? So let's see. I have 75 grams of ammonia. Now, remember I said the only way we can use the stoichiometry, because remember that says 4 moles of ammonia are reacting with 5 moles of oxygen to produce 4 moles of nitrogen and 6 moles of water. That's what those coefficients are telling us. So I have 75 grams of something. I've got to get it into moles of something. The only way to do that is by using its molecular mass. And I gave that to you. There's the molecular mass of ammonia. So I need the grams to go away. So the 17.04 grams of ammonia to 1 mole of ammonia. Cool. Let's check what cancels. I have grams ammonia divided by grams ammonia. X divided by X, 4 divided by 4. Anything divided by itself is 1. So I'm winning that. That's good. That goes away. That leaves me in moles ammonia. So in order to do any check, just a reminder, I've got to compare to the same thing. The question says how much nitric oxide can be produced. So what I'm going to do is compare both to nitric oxide, because the answer that I have here would just give me my moles of ammonia. It doesn't answer what is the least amount of my product I can create. So let's look at our stoichiometry. I need mole ammonia to go away. So my coefficient 4 there, it takes 4 moles of ammonia to make 4 moles of nitric oxide. Let's see, my mole ammonia will cancel out with mole ammonia. And my final answer is going to be in terms of nitric oxide. That 4 divided by 4 is going to become 1. So my math simplifies to this 75 on top divided by that 17.04 on the bottom. So 75 divided by 17.04. There we go. Means 4.40141. Let's talk sig figs. Let's see. Let me be more precise here. So I have 2 sig figs for the 75 grams. That means my final answer here can only have 2 sig figs. Multiplication division, fewest number of sig figs wins, and everything else is a given quantity that you could get from the periodic table. So this shouldn't limit your sig figs. If I wrote this down as 1, that's just because I truncated it, so it doesn't count. The 75 is the one that does. So my final answer is 4.4 moles of nitric oxide. Cool. There's the 1. Now let's look at our oxygen. We're given 150 grams. I think my dog wants to go outside. Of oxygen. Let's see, we're going to do the same thing. In order to use the stoichiometry, I've got to convert my mass to my moles. The only way I can go from mass of something to mole of something is with the molecular mass. So for my molecular mass of oxygen, it's 32.00 grams of oxygen per 1 mole of oxygen. And the temptation is to put a 2 up top, and it's because you doubled the mass of one single oxygen atom, but the O2 is accounted for that. So this is 1 mole of O2, not 1 mole of O, of oxygen itself. O2, the molecule, okay? So that, let's see, let's double check. Grams of oxygen cancels grams of oxygen. Beautiful. Now remember, this only works if I compare them both to the same thing. So I am back to 4 moles of nitric oxide over, let's see, my oxygen is a coefficient of 5, so that's 5 moles of oxygen. Not so pretty math here. Let's see, my moles oxygen cancel, my grams cancel, so this will give me an answer in terms of moles of nitric oxide. So it's going to be 150 times 4. When I hit enter, and then divide that by parentheses 32 times 5. Remember, multiplication division, everything across the top multiply, divide by everything on the bottom multiply. Let's see, 3.75. Oh, look at me. Moles of nitric oxide. What this says is I'm going to run out of my oxygen first. So oxygen is going to be my limiting reactant, and I'm going to have ammonia in excess. So there you have it. Smallest amount was actually the largest amount. And I'm going to switch things up to make it more funsies. So that's just a redo on writing chemical reactions. Make sure that you practice them because everything here just builds on this skill. So next one, we will do some ions.